What's up, guys? Today we're going to do a video on kind of an introduction to SMAW. I've got a little project here. It's a surfacing plate and then a T-joint that we're going to do in both the horizontal and vertical position. And this is a good little project that you can use to practice. The surfacing plate will give you a lot of arc time on a single piece of metal, which is really nice, especially if you're just first starting out. You've never stick welded before. This will give you an opportunity to lay down beads on the surface of a plate and just be able to surface the entire plate on both sides, which will give you a lot of arc time and give you a lot of time to sort of get the feel of the weld pool and how to manipulate the electrode and things like that. So that's a good place to start. So that's where we're going to start today. And I'm also going to talk a little bit about the technique for stick welding, what you want your travel angles to be, and your work angle and things like that as you progress through this weld. So this will give you a good basis to start on, again, if you've never welded before. But also, if you have stick welded before, but you just kind of taught yourself, maybe it'll give you some tips that'll help you out to get better, more consistent welds in the future. So that's where we'll start out. I'll show you how to set the machine. I'll show you some little tips and tricks on your technique, and we'll just go from there. Alrighty, guys, so this is the machine that we're going to be using today. It's a Miller SynchroWave 351. And this is kind of a beast of a machine. It's 350 amps. So most of you at home will be using something smaller than this. But the settings are pretty much the same. So I'm going to go over those with you so that you know at least how I'm setting up my machine. But every machine will be kind of similar. So the first thing I wanted to start off with is the terminals down here and what I have connected to each terminal. And basically you're going to have a positive and negative terminal on most machines. So this would be our positive terminal on this side, and this would be our negative. So we want to make sure that for this polarity we're doing DCEP, or direct current electrode positive, that we have our electrode connected to the positive terminal, which means that our stinger, or our electrode holder, should be connected to the positive terminal. And the negative the ground clamp should be connected to the negative terminal. And typically, even the newer machines, they will have designated, if they don't say positive and negative, at least they will have like a little picture of the electrode holder on one side and a picture of the ground clamp on the other. Now, for some of these older machines, if you wanted to switch that polarity, you would actually need to switch the leads. But for a lot of these newer machines, they just have a little picture there, and when you select a different process on the top, it's going to automatically switch the polarity for what you need. So they've kind of made it a little bit more user-friendly, or dumbed it down a little bit for us welders, whatever you want to call it. But a lot of the newer machines will do that. So this is a little bit more old school. You do have a positive and a negative, and you would hook it up as such. All right, so we're going to go ahead and turn the machine on. And it's pretty simple. To check that our polarity is correct, we have this selector here, and it's set to electrode positive, which is what we want for this particular electrode. We're using an E7018 electrode. It's Excalibur electrode. It's a low hydrogen electrode. It's very common for structural applications. It's kind of the industry standard. And the correct polarity that we want to use for this electrode is electrode positive. So we have a couple of selectors here. We can switch between GTAW or SMAW. We are doing stick welding, so we want to make sure it's up for stick welding. This selector here controls controls the amperage. So down here would be a remote amperage control, like a foot pedal for GTAW. We aren't going to be doing that today. We're going to be using the panel, which means that we go ahead and we adjust our amperage here on the panel. So that's what we want this to say, is panel. We want our output on so that the output is hot, meaning that when we short circuit to the material, the arc will start. So we want to set it up to on. for our output, not put metal. In terms of our high frequency, we'll get into that when we do TIG welding, but for this we don't need any high frequency, so we just have that set to off. Okay? Our amperage control is here, so we can adjust our amps, which will give us more or less heat. The higher our amperage, the more heat we'll have in our welding pool. The less amperage, the less heat we'll have. And actually, to a certain extent, when we get too low on the amperage, we'll have trouble getting the arc started and maintaining the arc. So I'm probably going to start off on cold plate with 1/8" electrode. I'm probably going to start right around 135, 140 amps. And then as my plate heats up, I'll probably start backing off of that amperage a little bit as I get more heat input into the plate. And that's the basic setup for this machine. Like I said, some of the newer machines can have different settings where it's a little bit easier to kind of know what you need, where you just set the process and it'll pretty much do the rest for you. So a little bit easier in that respect. If you have an older machine like that, then that's a basic setup for this machine. All right, let's get after it. All right, so the first project that we're going to work on is just a surfacing plate like I was talking about before. And you can see that we have this plate here. It has a bunch of welds on the surface. And this is actually something that you would do in industry where they do a lot of like hard facing on heavy equipment. As the equipment is used, it starts to wear down the metal thinner and thinner. So they may have you resurface the surface of the equipment with a real hard surfacing rod that will give it a new surface and extend the life of it. So, but in addition to actually being something that we do in industry, this is a good activity just to kind of get your training wheels off, so to speak, and to get a lot of arc time and perfect just running a bead on a flat surface before you try to do things that are more difficult. And so we're just going to run beads on the surface of this and try to surface both sides of this plate. And so before we even get started, we're just going to take kind of a dry run and show you, how to position your body, because you're going to want to make sure that you're really comfortable and that your body is stable as you're going through this weld. Because if you aren't feeling comfortable and your arms aren't, and your body and your arms aren't well planted, then you're going to see that in your weld and you're going to be really shaky and it's just not going to turn out good. But if you're firmly planted and you're comfortable throughout that weld, you can maintain those angles the same all the way through the weld, you're going to see that in the quality of your weld. So in terms of our body positioning, we want to get to where we can maintain a slight drag angle throughout the weld. You can see that we're not, straight up and down like this. We've got a slight drag angle, maybe about 20 degrees. And we want to be able to maintain that, lock in that angle all the way through our weld. Okay, we're also basically 90 degrees in terms of relation to what we call our work angle. Okay, so we aren't off to one side this way or this way, because we'll also see that in our weld. In order to get a nice consistent bead and weld pool, we need to be basically 90 degrees to the work this way, and then about a 20 degree drag angle. And we want to just maintain that throughout the weld. So that's pretty much how it's going to go. Okay, another thing that's really important is our stick out, or our arc gap. Basically in stick welding, the distance between the end of that electrode and the work surface, we want to keep that as tight as possible without actually sticking the electrode to the work surface. So we're going to go ahead and get our arc started by making just slight contact, like striking a match almost, on the work surface, and then we're going to try to keep that arc gap as close as possible. Okay, and the reason we do that is if we start to increase this distance, we start to get far away, that actually increases the heat in the weld pool. It makes the arc really erratic, and your filler metal will start to go everywhere rather than where you want it to go, which is right into your weld pool. So we want to try to keep that as short as possible. And one thing that's going to happen is this is a manual welding process, in that you actually have to feed in the electrode, right? You have to get closer to maintain that short distance as it burns away. So we need to make sure that we maintain that real short distance by feeding in that electrode as it burns away. Okay? So that's my basic technique. The only other thing would be travel speed, which you're going to want to watch that weld pool. You know, if the weld pool is just getting really huge and wide, then you know, okay, I'm probably hanging out too long here. I need to speed up a little bit. If it's real thin and sort of stringy, you know, looks like snot, then we want to slow down a little bit and let that weld pool fill up, okay? And you'll develop a sense for that over time, but at the beginning, you're really going to have to look at the shape of your weld when you're done and, you know, vary that travel speed based on that. All right, so let's give it a shot. All right, so I'm going to run my first little surfacing bead here. And, you know, one thing that you want to do, like I was talking about before, is make sure that you're going to be comfortable. So kind of get your body positioned, and you're going to want to take a little dry run through, you know, the entire length of your weld so that you make sure that you're not going to get caught up in anything, that you feel nice and comfortable. And it's just a good way to develop that muscle memory to make sure that you're going to put down a consistent weld, okay? So, you know, one thing you want to do is the machine's hot right now, meaning the output's on, the machine's on. So if I were to touch this plate, guess what? It's going to arc. So we want to make sure that we put our hood down before we do that. That way, you know, we don't accidentally strike an arc and get arc flash, which I've done plenty of times. So I'm trying to avoid that. All right, so we're just going to get that nice drag angle. You notice I'm not straight up and down. I've got a slight drag angle. And this is the way I'm going to move through my entire weld. Okay? So I feel pretty comfortable, so I'm going to go ahead and strike the arc. So one thing you may have noticed, when I got to the end of the weld, I tried to hang out a little bit. I kind of moved the electrode around a little bit, and then I terminated the arc. And the reason why you want to do that is to try to reduce the size of this crater. The end of your weld, this end part, is considered the crater, and that will be the hottest portion of your weld, so it'll have the most shrinkage as it cools. So that's why you want to put a little extra material at the end of the weld before you terminate the arc to try to eliminate that crater. Otherwise, that's the weakest area of your weld. So that's basically all that we're looking for. We're looking for a nice, consistent bead, you know, that's consistent in size to begin with, and you know, doesn't have any discontinuities like undercut on the sides or anything like that. If you're seeing a lot of undercut or a lot of irregularity, you know, usually the thing that I see the most is the arc spacing for new welders. They aren't good at, you know, feeding that rod in as it's burning away. So they end up long arcing and then you know, getting real close, and then long arcing again and getting real close. So you really have to work on being consistent. And when you have a lot of undercut, that's typically what it's from, is a real long arc. So just keep your eye on that and try to, that's usually kind of the last thing you learn, is being able to feed it in consistently while you're maintaining everything else. So just keep that in mind. Okay? So now we're going to have a little closer look at the arc, what it would kind of look like under the hood, and give you some pointers there. All right, so once you get that surfacing plate down in the flat position, then you're ready to move on to this horizontal T-joint. This is where it gets a little bit harder because now gravity comes into effect a little bit, just because the gravity wants to pull the weld pool down on that bottom toe. And also now you're actually, you're welding in the corner of the joint, so the weld pool is going to behave a little bit differently. But in a lot of ways, this is actually, it can be a little bit easier too. But a little bit different technique. The first thing that we want to look at is our angle here. And this would be in relation to the work. So we have a 90-degree angle in this joint, right? Our two pieces meeting in the corner here. And we want to be right at about 45 degrees, maybe just a little bit lower than 45 degrees to compensate for gravity as we move through. So that's going to be about what our work angle is, okay? Is just a little bit lower than 45 degrees. Now in terms of our travel angle, we want to maintain that same about 20-degree travel angle as we move through the joint. So this is basically what our angle is going to look like as we move through this joint. Okay? And everything else will be the same. We want to maintain a very short arc spacing and try to just maintain as much of a consistent travel speed as we can moving through the weld. We really want to watch the size of our weld pool. Again, if the weld pool is getting really, really big and kind of, misshaped, then we know maybe we're hanging out a little bit too long. If we're really moving too fast and we're just coming out with a very stringy little weld, if you can even call it that, then we want to slow down and let the weld pool fill up. But when we reach that kind of that middle road where our weld pool's filling up enough to where we're getting a nice consistent bead, then we just want to try to keep that consistent throughout the bead. Okay? So again, we want to really take a minute to figure out our body positioning as we move through this weld, make sure that we're going to be comfortable all the way through, and that we're nice and stable, and that we aren't going to be getting tired. Our arms aren't going to be getting tired from holding them up in the air as we go through this. We really want to be able to anchor our body against something as we move through this weld. Okay, so let's give it a shot. All right, so here we go. I'm going to take a little trial run again, make sure that I feel comfortable before I start the weld, but once I feel comfortable, then I'm just going to go for it. All right, so that was our horizontal T-joint. Hopefully that helped you out in terms of technique and how you can put a single pass down and have a nice, consistent, acceptable bead. But once you learn that, then to practice this even more and to conserve your material and get the most practice out of it, then you can start doing like a multi-pass horizontal. And that's also something that you're going to need to learn to do if you want to get into industry. You're going to need to be able to do multi-pass fillet welds, which means multiple passes stacked up to achieve a larger weld. So to do that, if you have a single pass fillet like this, then you would need to change your angles a little bit, because you're going to put two welds, two stringer beads side by side over the top of this and have a total of 3 beads. So to do that, you would want to cover just a portion of this weld, probably about 70% of the face of this weld you'd want to cover. So then you would need to turn your work angle a little bit more down. Point kind of just to the toe of that weld, or maybe just a little bit above it. And then you're going to change your angle to point more towards that bottom plate than previously. Previously, you were kind of at a low 45, something like that. Now you're going to bring that up to be a little bit more steep to get that bottom toe and to fill up about 70%, cover about 70% of that top of that first bead. And then when you go to put your second pass in, then you're going to bring your angle down quite a bit again, and you're going to point right to the middle of where that second bead ends, the toe of that, and this other piece of metal, so that you bridge the gap going across. So if I were to draw it out like a profile of what it looks like, if this is our T-joint here, this is the corner of our T-joint, our first bead should have a nice profile like that, equal size leg lengths on both sides. And then, our second bead should look something like that. You can see it covers about 70% of that first bead. And then, so our angle would be something like this. And then we're going to change our electrode angle to more something like this, maybe a little bit higher than that, to bridge that gap. And then overall, we can see that we still have this nice profile, still equal sized leg lengths. And so overall, we have a acceptable profile of our bead. And then we can keep going. We could add another 3 on top of that. Still overall, that same profile. And then we could add 4, and so on and so forth. So we could end up with quite a few. We could end up with a really nice doorstop when we're done. A nice heavy doorstop. And hopefully that top layer is something that you want your friends to see. So it could be a nice little memento for you. Memento. I don't know if that's the word. But anyway. It's a good way to get practice and get a lot out of one piece of material, and it's something that you'll need to do if you want to get out into industry and be a welder. All right, so now we're going to move on to vertical up, and this is where the game changes a little bit, because now we're going vertical, and we're dealing with a lot of different things, such as gravity, right? So now we're going to be changing our technique a little bit, and we're going to actually use a slight push angle. So if this is 90 degrees to the work, we're going to bring down our hands a little bit so that we have a push angle going up to compensate for gravity. And we're also going to do a slight weave pattern. So we're going to go from side to side in sort of a tight Z. Okay, so we're going to go side to side and pause on the sides. So kind of the rule is fast across the front, pause on the sides. Fast across the front, pause on the sides. So it's kind of looks like this in terms of our timing and our technique. And we just want to make sure that we're just slightly advancing up so that we don't end up, Z-weaving in the same spot too long and building up a lot of material. We want to try to get a nice flat bead going up, and the way we do that is just a real nice tight weave, but make sure that we're advancing up each time. And that'll give us a bead that's nice and flat. The goal of this for vertical up, no matter what process you're in, is to have a bead that basically looks like if you were welding in the horizontal position, but in the vertical. And this is something that takes a lot of practice, and a lot of welders that are even in the industry, have difficulty going vertical up. But for structural welding, vertical up is what we want to do. All right, so we'll run through a weld and I'll give you a little bit more pointers on my technique, and we'll go from there. All right, so one thing I wanted to talk about before I get into the welding is how important your body positioning is now, how even more important it is when you're welding out of position like this, because you know, it's hard enough to maintain a good technique, but if you don't position your body right, it can really make things a lot harder for you. For instance, the height at which your body is, right? Because you might start off at a position, you know, if I were down here like this, I might start off at a position where I can really see the weld pool, but then if I'm going to end up here, then my electrode's right in front of the weld pool. So I want to position my body so that I'm going to be able to see that weld pool over the top of that electrode all the way through that weld. And you know, in fabrication, that's going to be important. If you're doing a certification test, which going vertical up on a certification test is very, very common, you know, it's going to be really important because you've got to make sure that everything's good throughout that whole length of the weld so that you don't end up in a spot where, you know, things are getting kind of out of control. So I've done this a lot, so I kind of already know that I like my elbow up a little bit higher. That I like to start right at about this height so that I can end up in a position that's really, really comfortable for me. You know, I want to end in a position where I'm really comfortable, maybe start in a position that's a little less comfortable, because that's going to be the worst portion, is when I get to the end of this weld. That's when I'm really going to want to be shaky, or maybe, you know, things are getting hot and getting tired, whatever the reason is. I want to end up in the most comfortable position possible. So that's just kind of the way that I look at it. And again, we're going to want to have our hands a little bit lower so that we can maintain this push angle as we go up with a slight weave, Z weave as we go up. Another thing is I'm going to turn down my amperage, so maybe about 20%, you know, 15 to 20% in my amperage. I'm going to decrease it going vertical up. It's a much slower process, you know, weaving from side to side, and then also gravity is going to be wanting to pull our weld metal down and our weld pool down, so we need less heat in that, less fluidity in that weld pool. So that's why we're going to turn down. Okay, so let's give it a shot. One thing that I see is a lot of people will see this slag starting to drip down like this while they're welding, and they'll think that that's weld metal, so then they really start hurrying because they think that they're dwelling too long. So if you see some slag dripping down, that's normal. That doesn't necessarily mean that you need to go faster, because as you can see, even though there's some drip marks here of slag, underneath the weld is nice and flat still. So you know, don't necessarily think that when you see that dripping that means that you need to go faster, because then I see a lot of undercut and, you know, underfill left in here by newer welders. So just a nice slow even pace to get a nice flat face to your vertical ups. Alright, so that's it for our flat surfacing weld, a horizontal fillet, and a vertical fillet with SMAW, also known as stick welding. I hope that some of the things that I talked about in this video will help you out with your own technique and your own quality of welds. You know, hopefully you can use this to improve the overall quality of your projects. If you like this video or if you found it helpful, please don't forget to hit that like button. Also, subscribe to the channel. I'll be uploading a lot of welding videos in the near future, various processes. I'll kind of start off with stuff like this, more beginner, just getting into the processes, and then as we go forward, I'll do some things that are a little bit more specialized. So if you like the video, please give it a like, and don't forget to subscribe to the channel, and thank you for watching. All right, we'll catch you next time.